Okay, hello everybody, and welcome to the Multi-Medix webinar series on ultrasound probe testing. This is the first webinar in our series of 3, and this one is on FirstCall, what no one ever told you. We're going to do a little bit of introduction first of all, tell you about ourselves. Then we're going to go into the webinar itself, which will be led by Darren, and then there'll be 10 minutes at the very end, which is a question and answer session. If you would like to participate in the question and answer session, then and you're watching this live, then please just click on the chat panel, which is the little speech icon at the bottom of the Zoom screen, and a chat panel will open. Please be aware that this webinar is being recorded, so if you'd prefer not to be recorded, then feel free to leave the webinar now. It is being recorded, so therefore you'll be able to watch it on the Multi-Medix Knowledge Portal tomorrow. It'll be on there tomorrow. Should you have any difficulty seeing or hearing the webinar at all, for those of you that are watching it live, then please just put a message in the chat panel, and I will then try and endeavour to solve your technical difficulties. I'll also put my email address in the chat panel as well if you need to email me with any technical questions. My name is Marilla Stevenson, and I work for Multi-Medix along with Jen and Darren. And let me just introduce you to Jen first of all. She is our US Managing Director, and for those of you in the States, you may well recognise her because she's worked in the industry since 2005, so she really knows her ultrasound stuff. She worked for over 15 years for Trisonics, which is a leading ultrasound service company on the east coast of the States, and we're really proud to have her working with Multi-Medix now. So I'm going to slip into the background now and hand you over to Jen, who's going to tell you a little bit more about this webinar and introduce Darren to you.
Thank you, Marilla. As Marilla stated, I will be your direct contact for all your probe needs, whether that be probe repairs or probe sales. So post-webinar, I will send all of you an email so you have my direct contact information. So please feel free to contact me at any time. I will answer any questions that you may have. Darren, who I work alongside, is our technical director. He's been in the ultrasound industry for 25 years and is an electronics engineer and a biomed by trade. He's published several papers on the subject matter, and he's also implemented our ISO 13485 at our facility. As Marilla said, at the end, we're going to have a Q&A session. So I will see you all at the end, but I'm going to turn it over to Darren now, and we're going to get started on the things you didn't know about FirstCall.
Thank you, Jen. Yeah. Hello, everybody. I'm looking forward to try and share some knowledge with you today on some things that perhaps nobody's ever told you about FirstCall, and certainly some things I wish I'd known when I was first using it in the past. Firstly, just a little bit about us. We class ourselves as kind of leading people in the arena of probes in ultrasound. We've implemented a 13485 sales and repair facility. We trade globally with MVS and direct to healthcare organizations. We do repairs for end users and all other kinds of people, including the major OEMs. We also offer quality assurance services and training. Anyway, let's get over to the main subject matter today, probe testing with the FirstCall. And we can substitute the word probe hunter into there if we need to, but I'm just going to keep it simple today because most of us know FirstCall and its family of adapters and everything else we use. So what is FirstCall? Well, it's a specialist test bed that was designed to allow us to test ultrasound probes without the need of a system. It's got many advantages and a few disadvantages, like most things. It's made up of a base unit, which we connect to a computer and run from software so we can address and test the probes. Some of its advantages are it gives us very definitive results, which is very helpful. It allows us to do root cause diagnostics when we've got defects. It's very flexible because a single adapter allows us to address many, many different makes of probes. And like I've already said, no system is required. Disadvantages are it's reliably expensive. So those of you who've got one know that it costs quite a lot of money initially, and it also continues to cost money if we add adapters. It's not particularly portable. So a little picture of it there for those who are familiar, but we need a water bath, a target, various adapters, a base unit, a computer with a monitor. So I wouldn't say it was exceptionally portable, but it's great in our testing facilities for sure, and your biomed labs. And I would also say that it's easy to get an incorrect result, so a good amount of training is required to be able to use it correctly. So what does it do? There's the first question. Well, what it does is two different tests. The first one is what most of us focus on, and this involves us placing the probe into our target, aligning the probes to the target to get maximum receive. And this target is placed into a water bath where we're going to send an electronic pulse into our transducer array. We're going to transmit, which is going to convert the energy into an acoustic wave. It's going to bounce off our target, and we're going to get a received signal back, which is going to transfer back into electronics. And our FirstCall system is going to record that and give us some key information about the performance of our array and its individual elements. We're also going to do an individual element capacitance test. Now, we don't actually need to be in the water tank for this, but it usually runs automatically whilst we've still got it in the tank. And that's going to tell us something about the electronic characteristics of our cabling and our array assembly. And that's really useful because that tells us a lot about the defects that we might see. I'm not sure how many people focus on the capacitance graphs in the reports, but it does start to tell us some really useful information. So what does our reports look like? Well, hopefully there's the reports we all know and love. So we've got a nice 3-page report. First page is the one that nearly all of us spend most of our time looking at, including me. So on our first page, we've got our sensitivity graph and our capacitance graph. Sensitivity, we're normally looking for element performance to be above the 75% mean, which is the horizontal green line. But our other pages also tell us some really useful information, such as our center frequency, our bandwidth, and our frequency response. And that can tell us a lot about the probe as well. But we're going to focus mainly today on sensitivity and capacitance and how it can give us a really good readout on what's going on inside your probe. So before we do that, I'm just going to do a little refresher in what makes up a probe for us. So our probe is made up of several components, and it doesn't matter whether it's in a linear configuration or a sector configuration or a curvilinear configuration like this diagram. So what we have is on the top facing the patient, we have our acoustic lens material, usually some kind of silicon membrane. Below that, we'll have the matching layers and actually acoustic array, which is the piezoelectric material, which transmits and receives the energy. Behind that, we'll have a backing circuit, and all of that is optimized by the OEMs to transmit energy as efficiently as possible. Connected back to that will be a microflex circuit that allows us to connect that over to the micro coax cables. So essentially what we've got is a coax cable with its own unique capacitance characteristics and reactance connecting to a piezoelectric material, which effectively acts as like another little capacitor with the actual array material, which isn't directly conductive, acting like a dielectric layer. So what we can see from that capacitance is it's just a circuit in our terms, and that allows us to understand the electronic characteristics using the FirstCall of our circuit and its performance. So before I go on and just explain how the different graphs can tell us exactly what's going on with our probe, let's just define what's good performance and poor performance of an element. So what we say is acceptable performance is usually above the 75% mean, because we do want element to element consistency, because that helps create consistent beams within the profile of the ultrasound system and probe. A poor element is where it's giving some level of performance, but it's not performing as intended. So we would characterize that between 10 and 75% of mean sensitivity. And a non-functioning element is where we would say that it's giving less than 10% sensitivity. So it's not really effective in creating the beam. So let's move over to this slide, which is one of the most important on the webinar today. And what it allows us to do, if we get a mix of low, medium or high sensitivity, and the same with capacitance, and we look at their adjacencies, we can start to diagnose not only that there's something wrong, but what's wrong. So over on to the first part of this graph, you can see that if we completely lose sensitivity and we've got no acoustic performance, and we've got a small drop in capacitance, by understanding how the electronic characteristics and the makeup of the probe are, we can actually define that what we've got is The remaining capacitance there is made up of the cable, because the cable is the main part of the capacitance. So a small capacitance drop means that we've got an open circuit going on where the element is, and a lack of acoustic performance tells us we truly have non-functional or dead elements in their truest sense. Moving along, we can see that if we've got all of our capacitance working correctly, therefore we know we've got a good circuit. However, we've not got acoustic performance due to delamination, but we have got a little bit of performance. So that means that we understand that something's gone wrong in the layers of the array, and it's usually the lens material coming away from the matching layer, and that's stopping acoustic performance. If we've got a drop in performance and a small drop in capacitance, what we've got there is a degradation of the individual piezoelectric elements, and that really means that what we've got is what we call weak elements. So they're creating some kind of acoustic performance, but not as intended, and maybe affecting the image. Moving further over, if we lose a lot of the capacitance and all of the sensitivity, we can clearly identify by understanding how reactance works with capacitance that that's a cable break, so that's an open circuit. And if we get a spike in capacitance and no performance, we can see that that's another cable issue where we've lost our sensitivity due to a cable short, so we're not able to transmit the electronic energy. I wish somebody had told me that right at the start, but I've made it really simple for our team, and we're here today to try and share that with you. So in summary, a good array would have good sensitivity and capacitance across all of the elements. However, some level of defect would have either dead elements, where we've got no sensitivity and only a slight reduction in capacitance, delamination, where we have got a reduce in sensitivity but a normal capacitance, weakened elements where sensitivity and capacitance are both decreased. We've got cable breaks where we have no echo, so no sensitivity, and a significant drop in capacitance, and a cable short where we see a spike in capacitance but no sensitivity in the echo. So how does that look in real terms? Well, this is a real probe. So it's actually this probe. It's one of the training probes I use when we're doing education sessions, because it's a good example. And what we can see is a few different types of faults there. So we can see over on this side, if you can see my mouse, that we've got some delamination, because I can see that I've lost most of my sensitivity, but not all of it, but I've retained below that all of my capacitance. So that basically telling us my circuit is entirely intact, but I'm not transmitting acoustic energy, and I've got delamination. And I know that's true because that's in this region of the probe, and whilst it's difficult to demonstrate on the webinar, we know we've got classic delamination going on in that area of the array. Moving along to the other side, and we can see multiple examples of this across this report, is we've got some dead elements where we've entirely lost the sensitivity performance. So we've got no acoustic transmit and receive, and that's because we've got dead elements, because I can see below that we've got a level of sensitivity that remains on this particular probe. So that tells me a lot. Rather than just I've got a defective probe, I can now say I've got a defective probe for certain reasons, and that can help us either with repair options or even understanding whether there's been problems with good care and use by the sonographers and the users. Now, this might be a good time to point out that many of you be getting frustrated by a lack of profiles available for new models of probes, and that's something, by understanding FirstCall very closely, we've been able to overcome with some development of our own. And if you're interested in talking to us about that a little bit, I'm going to suggest you contact Jen, and she'll be able to create a dialogue with you, and we can talk a little bit about that away from the webinar. But what does this probe look like in real use? Well, one of the strangest things is, whilst we can see this is very defective and we've got lots of dead elements, this is what the initial image looks like in the air reverberation, ready to do a standard carotid exam. And whilst I, as a very experienced person looking at probe performance, can start to see degradation in that reverb pattern, a lot of people might just get gel on that and put it on the patient, and that may mean that they miss clinical information. However, with careful optimization of the ultrasound scanner settings, we can actually really see the impact of what our FirstCall report showed. So I'm going to show that on the next slide. So here we can see much clearer dark vertical streaks. And this area here is our delamination. And I'm going to go back 2 slides. So we've got our delamination and dropout going on here, and then we've got many incidents of dropout. And by optimizing the scanner settings, we can actually see that in the field setting. And that's a topic that we're going to talk about more on our second webinar on the 15th of April, where we're going to teach you, if you're out in the field and you've not got your FirstCall available, or you don't have a FirstCall available, how with the use of a specially designed test tool and a protocol that allows us to optimize the scanner settings, we can identify equivalent of that FirstCall test result. We may not see the full root diagnostics, but we can get the same understanding of defects on the probe very quickly, very easily, in less than 5 minutes, with just the use of a specialist small test tool, which looks like this. So I hope you found that very interesting, and we're going to open it back up to questions, and I think Jen's going to join us to help us with that. So please feel free to open up the chat panel, which I'm going to do as well now, so that we can see if there's anybody that's got a few questions. And I think Jen may also have some questions from some people that weren't able to join the webinar and already wanted to ask us some questions.
Sure. Yep. Thank you, Darren. So as Darren said, if you have any questions, just please put them in the chat window. We did have some previously submitted by those who weren't able to watch live today. So we'll start with this one for you, Darren. So one question was, what about testing matrix probes that the FirstCall doesn't support?
That's a good question, Jen, because the FirstCall is a fabulous system. It does test a few of the matrix probes, especially the GE ones like the M5 SCD, which I will call like a 1.5D probe due to its configuration of elements with 3 rows. However, when we get into the high density matrix probes that they now make, such as the Philips X51, there isn't a commercially available solution for that. So what we've done using the same test tool, Jen, is to develop, once again, specialist protocols that allow us to look at rows of dropout and performance. It's quite an advanced test, and we're very much looking forward to being able to offer that as an advanced course online for those people that are interested.
Okay, great. A second one was, how do I access help with FirstCall profiles? I know you mentioned that a little bit earlier, but do you want to go into a little more?
I think, Jen, let's have people tell us what adapter and make and model of probe they're struggling with, because that's what we need to be able to answer them specifically. So for those experienced FirstCall users out there, we all know we've got different configuration of adapters that are designed to fit different styles and makes of probe. So for instance, the GERS or the Philips CX50 and Epic. So whilst they look technically the same, we do need different adapters. And then we'll be able to advise whether we can help with some profiles that people have been struggling with. There's naturally a few specialist probes, like we've already talked about, the matrix probes, that won't be applicable in that section. But if they want to reach out to you, Jen, either directly on your email that you put on the chat panel or into one of the email addresses on the screen, I'm sure we can help a lot of people with that. Certainly, the product is not nearly as obsolete as people think it is.
And I can absolutely help anybody with that. So as you saw, my contact information was up on the chat, but again, I will send everybody an email with my contact information so I can help answer those questions. Another one was, how do I read results that don't have a capacitance chart?
Another good question, Jen, actually. So there are some multiplex probes where we can't get a direct circuit through the multiplexing sequencing. So this is typically where there's more channels on the probe than there are cables on the actual probe configuration. So if I've got this probe as an example, this is a 192 element probe, but there's actually 192 microcoax cables, so we can get a direct circuit. But there are probes with up to 300 plus elements even in a traditional array format like this, and maybe only have 128 cables. So what we have to do is rely on sensitivity and a few other system tests that we have available. So that will be configuring a system alongside the FirstCall to help us do root cause diagnosis. But it's all manageable with a series of tests but that's what we would do. But the sensitivity leads us down a pathway, which we then use system testing to complete the picture.
Okay, great. And then one final one that I had is, how do I find out about repairs you can do? So I can kind of cover that, Darren. So I can help any one of you with any probe repairs. We offer free loaners. Just contact me and I can provide you with a compatibility matrix that Darren updates all the time. But if it's something that you don't see on our matrix, certainly still reach out to me and give me a call. Again, we can help you out with any repairs, and again, free loaner, 6-month warranty, quick turnaround time, and definitely for me, customer service is very important. So I will be your contact and would love to help you out on any of that. Do you have anything else to add to that, Darren?
No, Jen, I just want to thank everybody for taking a little bit of time to watch this. Please contact Jen for questions, and I'll work with Jen in the background to support her. And thank you, Jen, for this opportunity to do this webinar with you today.
Yeah, and I just wanted to add that the test tools will be sent out April 7th, and that our next webinar is Thursday, April 15th, and that is instant results with your Multi-Medix tool. So if anyone would like to join, or know colleagues who would now like to join that or get a free test tool, please show them the registration form at multimedix.com. So I thank everybody for attending, and everybody have a great day.
Thanks, Jen.
Thank you. Bye-bye.
Bye-bye.